Hello, this is Miss D again. Today we're going to be exploring how we can solve multiplicative comparison word problems involving fractions. So let's get started by looking at slide I. We're going to answer the questions on the left one at a time, and we're going to read this story 3 times. So let's get started with the first read. A seamstress needs 1 5/8 yards of fabric to make a child's dress. She needs 3 times as much fabric to make a woman's dress. So let's go ahead and answer that first question. What is happening in that story? So pause and think, and when you're ready, unpause. So what's happening in this story? Well, did you say that the story is about a seamstress that is making a dress for a child and a dress for a woman? Great. Let's go ahead and read it another time, and we're going to answer 2 questions. So a seamstress needs 1 5/8 yards of fabric to make a child's dress. She needs 3 times as much fabric to make a woman's dress. So we're going to answer the questions, what are the quantities in the problem? And you can go ahead and use those sentence starters to help you. And then we're also going to be answering the question, what relationships exist? So go ahead and pause and think about those 2 questions, and when you're ready, unpause. All right, so what did you come up with? Did you notice that the seamstress needs 1 5/8 yards for a child's dress? Did you notice that there was just one seamstress and she has to make these 2 dresses? One is a child's dress and one's a woman's dress. Did you notice that she needs 3 times more to make the woman's dress than she does for the child's dress? Did you also notice we don't know how much the woman's dress is? I mean, we could figure it out, but they're not really telling us that amount. All right, what did you come up with for what relationships exist? Did you maybe think that we know that there's a relationship between the woman's and the child's dress? Did you notice that the woman's dress is 3 times as much fabric as the child's dress? Did you also think about the woman's dress is bigger than the child's dress since we need more fabric for the woman's dress? Did you think that we can find the total amount of fabric? And maybe you also thought that we could find the difference between the amounts for the woman's dress and the child's dress. Great job there, guys. All right, we're going to read it one last time here, and we're going to answer that one last question. So a seamstress needs 1 5/8 yards of fabric to make a child's dress. She needs 3 times as much fabric to make a woman's dress. So let's go ahead and answer that last question. What are some mathematical questions you could ask about this problem? So go ahead and answer that question, and when you're ready, unpause. So what were some of the questions you came up with? Did you ask how much fabric does she need all together for a child's dress and a woman's dress? Maybe one of your questions was, how much fabric does she need for the woman's dress? Maybe another question you came up with was, how much more fabric does she need for the woman's dress than she needs for the child's dress? Well, great job there, guys. We're going to move ahead to the next slide. So let's go ahead to the next slide here. And I want you guys to draw a picture or a model to show the quantities and the relationships. So how can you represent these? What could you draw? You can use the graph paper here, or you can use any other tools that you want. All right, go ahead. When you're ready, unpause. So what did you come up with? Did you maybe draw a picture of the 2 dresses? So here we have the woman's dress and the child's dress, right? We know that the child's dress is 1 5/8, and we know the woman's dress is going to be 3 times as much as the child's, right? So 3 times C, right? 3 times that 1 5/8. Did you maybe draw a bar model that shows the relationship? You have the child's dress is 1 5/8, and then we know the woman's dress is 3 times that amount. So we have here 3 groups of 1 5/8. Maybe you drew a number line to represent the child's and woman's dress, right? We have here the child's dress at 1 5/8, another 1 5/8 to show first group for the woman, the second group for the woman, and the third group ending here. All great options here. Great job, guys. All right, let's move ahead to the next slide. So now we're looking at the same problem, but we've added the question. So let's go ahead and read this one more time. A seamstress needs 1 5/8 yards of fabric to make a child's dress. She needs 3 times as much fabric to make a woman's dress. How many yards of fabric does she need to make both dresses? Okay, so now we know the question here. I want you guys to go ahead and think about this question and try to solve it in the space provided. If you want to, you can go ahead and click that link here for some tools to help you with your work. All right, guys, you go ahead and pause. When you're ready, unpause. All right, so what did you get? How did you solve this? Let's take a look at 2 possible ways you might have solved this. Let's look at slides L and M. So we're going to start here with student A on slide M. What do you notice? What do you wonder? Pause and think. All right, so what did you notice here? Did you notice that they drew a model to represent the child and the woman? Did you notice here that they solved first for 3 times 1 5/8? And did you notice they used the distributive property? Right, they did 3 times 1, 3 times the 5/8. And we kind of see that here in the model, right? 3 groups of 1, 1, 2, 3, right? That's this part here. And then you should also be noticing that they then did 3 times the 5/8, right? Because we have 3 of those 5/8, right? You can count that really easily. 1, 2, 3, right? And then 5/8, 10/8, 15/8. And then they found out that that was 4 7/8. And then we noticed that they added 1 5/8 because we had to find out how much total fabric she used for the child's dress and the woman's dress. So I see they took that total here, that product, and then added the child's dress here to get an answer of 6 4/8. Is that the way you solved it? Yeah, I think this is the way I would have solved it too. All right, let's go ahead to slide M. So we're going to look here at student B's work. So I want you to go ahead and want you to jot down what do you notice, what do you wonder, and when you're ready, you can go ahead and unpause. So what did you notice here? Did you notice they also drew a bar model here to represent the amount of fabric used for the child's dress and the woman's dress? Did you notice that they solved for 4 times 1 5/8? And they also used the distributive property. Did you notice they used the distributive property here? If we go ahead and highlight here, we see that I'm guessing they did 1, 2, 3, 4. So they solved for the total amount for the child's dress and woman's dress at the same time, right? And that's where we get 4 times 1. And then they have those 4 5/8 there, right? 5/8, 10/8, 15/8, 20/8, right? And we see that 20/8 there. And then they also found their answer to be that 6 4/8. All right, let's go ahead to the next slide and compare the 2 different ways. So how is student A's thinking similar to student B's? How is it different? So go ahead and pause and think. When you're ready, unpause. Okay, did you guys notice that they drew the same model? So both student A and student B had that same model to kind of refer to help them with their thinking. Did you notice that both of them found that total of 6 4/8 fabric for both the child's dress and the woman's dress? Did you notice that student A had a multiplication sentence and an addition sentence to help them solve this, while student B just had a multiplication sentence here to help them solve this problem? Right? Did you notice that here we had 3 groups plus an additional group, and here we just had those 4 groups? Well, we've come to the end of this video segment. Continue exploring the other slides for more practice. I hope you found this video on how we can solve multiplicative comparison word problems involving fractions helpful. You guys did a great job today. I'll see you next time.